Anyhow, so 9-5 today. Depending on the day, I might have to do a little Zoom on Friday with y'all, okay? We'll knock out 9-5 today. And then next week, 9-6 and 9-7. I'm gonna shorten 9-7 down because it's just using equations. And after that, all y'all got left is just doing all y'all tests being done. Right? I will that last Monday in class do my final exam reviews and stuff. Like May 1st or whatever that day is.
Will you be doing a review before the final?
That's what I was talking about that last Monday.
Is there going to be a test 4 then?
Mm-hmm. Yeah.
When will the review for test 4 be?
I'm going to try to do that next week. So if y'all, probably that Friday. And then I will send a review out. A video for it also. The file's not bad, but it does have a few of them bad questions, like with the ladder hanging on the wall type stuff. And it works on like that, where you have to do the Pythagorean theorem and stuff. So it's not too bad though. Okay. All right, so we're going to look at properties of logarithmic functions. These are going to help us solve logarithmic equations next class, okay? So let's go through some of these properties. And these properties sort of mirror exponent rules since logarithms are really exponents, okay? So I've got the product rule of logs. And the product rule tells me that if I got a log of a product, so the log of a product can be written as a sum of the two logs. So I can write that as a log base A of m plus the log base A of n. So you sort of distribute the log base A to both of those and rewrite them as a sum. And I always remembered that because I knew when I multiplied variables, you had to add them exponents, right? Remember, these are really exponents we're dealing with here, okay? Power rule of logs. So the power rule, you start with something being raised to an exponent. Now before, when you had, say, x squared raised to the third power, you multiplied those exponents. So the trick on this is to bring that p down to the front and multiply by the log base A of m. So in the long run, you're still multiplying in exponents on that power rule, okay? So just remember, all I do is just bring that p down to the front and we're done, okay? And then I'll do examples working through all these for you, so to show you what they're going to do. Next, we got the quotient rule. Of logs. So if you remember this, when you were dividing variables, like you had an x to the 5 over an x squared, you subtracted those exponents. So the quotient rule, I'm going to take log base A of m divided by n. I'm going to distribute the log to both of those and rewrite it as subtraction. And it's always the top minus the bottom, okay? All right, let's see. Log of a base to a power. I got log base A of A to the X. Anytime you see something written in that pattern, the actual answer will be X. And I'll tell you the reason that is, because using the power rule, you would bring that X down to the front. But the log A of A, that part equals 1. Because anytime the base matches that result, it's a 1 there, okay? All right, then the last one you want to look at here, base to a log power. So now that I'll have A raised to the log base A of X. And in the long run, y'all, all that equals is A X. All right, so we'll focus on these three for sure. Water rule, power rule, and my quotient rule. But if we see some of those things, we can simplify it quicker, okay? All right, so I'm going to start going through these little properties. Let me get these more here. In most of these properties, I got 2 questions from each. So use one using regular logs and one doing LNs. Okay. So the first one is we're going to express as a sum of logs. And they're giving me log base 22 of 22 times 484. Now this one, they didn't say simplify all the way down. They just wanted me to rewrite it as a sum. So this goes back to the first property I put up there. I'm going to distribute the log base 22 to both of those. So I'll get log base 22 of 22 plus log base 22 of 484. It's not too bad. You just got to get used to when they're being multiplied, you write them as a addition, okay? Now, like I said, the next one they're doing LN. LN of B times C. So we're going to distribute that LN to both of these factors. So I'm going to get an LN of B plus the LN of C. So question don't rewrite them as addition. All right. Next, we're going to rewrite as a product. So express as a product. And the rule that let me express things as a product was the power rule, where I brought the exponents down to the front and rewritten it as a product, okay? So I got one of each of those. Log base 10 of S to the 15th. So all I'm going to do is what? Bring that exponent of 15 down to the front so that this becomes 15 times the log base 10 of an S. on that? I'll tell you, the moral of the story is on this one, anytime you got exponents like that, you're gonna bring them down to the front of these logs, okay? So I'm gonna pull a tricky one then, see what y'all's memory has on these radicals. I'm gonna do ln of the 4th root of a 6. In order for me to use my power rule on this, we're going to have to rewrite that radical as a fractional exponent. Okay? So to rewrite this radical as a fractional exponent, I'm going to bring my ln over, my 6, and then we're going to figure out what that exponent is going to be. I will say this, since the 6 don't have a exponent by it, you would treat it like a 1. So the top number on a radical, when you rewrite it as a fraction, is going to be a 1. The bottom of that fraction is the index of that radical, which is the 4. So to rewrite a radical as a fractional exponent, it's just 1 over whatever that index is. Unless you got another exponent sitting by that number down here, okay? So now, I've rewritten down the radical. Now, to finish this out and rewrite it as a product, I need to take that 1/4 and bring it down to the front. So that this becomes a 1/4 times the ln of a 6. Okay? And so you'll do that every time you got exponents, you want to bring them down. Okay? So next it says express as a difference. So now we're looking at that quotient rule. So express it as a difference of logs. And I've got log base R of D divided by 3. So once again on this one, we got to distribute the log R to the top and bottom, and then rewrite it as subtraction because that's what they're telling us, okay? So it's always the log of the top, so log base R of D minus the log of that bottom, which will be a log base R of a 3. So, y'all good? Mm-hmm. So that would have been 5, my bad. And then 6, we're going to do it the LNs, remember? So this is ln of m divided by t. Now, y'all, one thing I will say on this, math lab is picky about capital letters and lowercase letters. So if they give you capital, you got to make it capital, okay? So both of these were actually lowercase, but this one had a capital D on it, okay? So got to watch some of them examples. But the same thing, right? ln of m minus ln of the t. So as you're getting warmed up, so now comes the good ones. So questions on that, online or in class? All right, y'all, here we go. Then we'll start turning them up. Rewrite as sums or differences. So rewrite as sums or differences. So did y'all even mess with logs in high school? I didn't think so. This is probably something new then. So the main thing on these logs, you just got to remember they're exponents. And they're going to follow all the exponent rules, okay? So we're going to rewrite it sums or differences. So they're giving me ln, and in parentheses, x to the 4, y to the 6, z. So let me tell you this, all these are being multiplied. So since they're all being multiplied, I'm going to use the product rule and write them as addition. So I'm going to rewrite all these as addition and distribute the ln to everybody. So you're going to get an ln x to the 4 plus an ln y to the 6 plus an ln of z. Now, this one's not done yet. Because this one, they want me to go as far as I can with this. And there's only one thing I'm going to do today. Y'all know what it is? Think of this product rule.
I'll move all the exponents to the front.
I'm going to bring all the exponents to the front. Good job. So this 4 is going to come to the front of this ln, and the 6 will come in front of that. So then I get 4 ln x plus 6 ln y plus my ln of z. So good job. Anytime you see them exponents up there, to be totally simplified, you're going to have to bring them down, okay? That's the only thing that's too bad. Okay, maybe I get more room on this. All right, here's the fun one. I got log base b, p to the 4th, q to the 5th, all over, m to the 3rd, b to the 9th. Now, all rules are in play on these, okay? The first thing I'm going to do, since it looks like division, is I'm going to rewrite it as sums and differences. Now here's the trick. If it's on top, when I rewrite it, it'll be positive. If it's on the bottom when I rewrite it, they will be negative because they're on the bottom of that fraction. So the bottom will be rewritten as negative. And remember, it's always the top minus them bottoms, okay? So to rewrite this out, my first step would be a log base b of p to the 4th plus a log base b of q to the 5th. Both them factors were on top, they got to be positive. Now, everything else is on bottom, so this would be minus log b of m to the 3rd minus log b of b to the 9th. So 3 of them I'm going to do something to, and then the other one I'm going to do something different. But for the first 3 terms in that, guess what I'm going to do?
Move to the front.
Bring them exponents to the front. So the 4 is going to the front, the 5 is going to the front, and the 3 is going to the front. And y'all, technically that 9 would go to the front, but I gave y'all a property while ago that said if that base matches that result raised to an exponent, then that that's just going to give me a 9 in the long run, remember? Because these are the ones where I had log base a of a to the x equal to x. Okay? So this will give me 4 log b of p plus 5 log b of q minus 3 log b of m minus 9. Okay, so remember, anytime that base matches the base raised to an exponent, in the long run, it's going to equal that exponent. That's probably one of the worst ones I'm gonna hit you with. So y'all, now you have to remember, tops are positive, bottoms are negative. Bring the exponents down and then take care of that. Okay. All right, same thing with the LNs. ln of 2 divided by 9x to the 9y. So once again, if it's on top, it's positive. If it's on the bottom, it's going to be negative. And I'm going to distribute that ln to everybody. So I'm going to get an ln of 2 minus ln of. So here's the question. How many factors y'all got on the bottom of that fraction?
2.
What did you say just then?
3.
3. Because you got the 9, the x to the 9, and then the y. So you're going to have to distribute all them down here. So you get minus ln of the 9 minus ln of x to the 9 minus ln of the y. So good job. A lot of people treat the 9x like one factor, when actually it is definitely 2. Okay. All right, one more thing to do.
With the exponent to the front.
So bring this exponent to the front here. So ln of 2 minus ln of 9 minus 9 ln of x minus ln of y. Now, I'll tell you what's sad about logarithms. In regular math, the problems get smaller and smaller as you go through them. These ain't really getting no smaller. You're just rearranging them, you know, but you're still stuck with all these terms. You got to keep bringing down, okay? All right, how about a log square root C6D? So I'll probably play with this and babysit through this. But the first thing I'm going to do is rewrite that radical. Now notice there's 2 things under the radical. So when I rewrite it, I'm going to use parentheses to put my C6D into. And then on the outside, I'll write my exponent. So what's this fraction going to be? It will be a 1 over something. But that radical don't have an index on it. That square root is sitting there. It ain't got an index on it like I had one go with my 3 or 4. So it's automatically a what?
1 or 2.
2, there you go. So a square root is the only index that I don't have to put the 2 on. So if you see a little radical on the calculator, it's automatically doing square roots. Cubes and 4s and all that, you have to use 1 with the 3 sitting there or whatever. Now, we're going to distribute that exponent by multiplying, okay? So that's going to give me a log C. So what is 6 times 1/2 going to give you? 3. So I get a log C3. In a D, well, it's just got a 1 there, and 1 times 1/2 is going to stay at 1/2. Okay. So you got a product there. So to rewrite the product, we're going to write it as addition. So that'll give me a log C to the 3rd plus a log D to the 1/2. Well, one more step.
You gotta move it to the front.
Yep, they bring them boys down, guys. So 3 log C, what's that, a 1/2 log D. So to me, they're really being tricky with these radicals. So y'all make sure we know what we did here, because I got a big radical coming up. All right, here comes the big boy, y'all. Log base C. So log base C. And then they got big parentheses. And then here's a big radical with a 4 here. I got an M8, N20 all over, a C7, and an A5. So I'm going to rewrite it with the radical gone for my first step. I'm going to bring down the log C. I'm going to keep everything in parentheses still. M8, N20 divided by my C7, A5. What is the exponent going to be?
4.
So 1 over
4.
4. Perfect. And I'll tell you, if you wanted to find like fourth roots of stuff, you could use exponents of 1/4 to do the same thing that you could with the radical stuff. Okay. Next, we're going to distribute this exponent to everybody inside these parentheses. So I'm going to get log base C. Well, 8 times 1/4 will give me M squared, right? 20 times 1/4 will give me N to the 5th. So basically, when you multiply by 4, you're just taking these numbers and dividing by that 4. Oh, 7 won't divide by 4, so that's going to stay C 7/4. And then the A, the same thing. That's going to stay A to the 5/4. So we haven't done nothing yet but rewrite it out of that radical, y'all. Now, if it's on top, it's going to be added. If it's on bottom, it's going to be subtracted. Distributed log C to everybody. So log C of M squared plus log C of N to the 5th. And then it's minus log C of C to the 7/4 minus log C of A to the 5/4. So we know what I'm about to do, right? I'm about to kick all these exponents up, except for this one right here. That third term is a log base to the base to an exponent. Remember, anytime this base matches the result raised to an exponent, that's just going to equal the exponent. Okay? Oh, okay, so let me see what I get here. I get a 2 log C of M plus I get my 5 log C of N. Remember, since this base matches this result to an exponent, that's just going to be minus 7/4. And then at the end, it'll be minus 5/4 log C of A. So y'all, what I'm really wanting y'all to focus on are these things that are just turning into these exponents on these. Okay? Focus on them exponents when them bases are matching. All right, which one you looking at?
That little circle thing you did,
That I just did? This
what does that say?
log C of C to the 7/4. And I'm just circling it, just remind y'all that since those bases were matching, that's just going to equal the exponents on those. Okay? That's probably the craziest one because it's got so many things in it, okay? And you have to do all the radical converting on some of those. We used to do a lot more with fractional exponents, but these days, when they always cut stuff, that's one of the things they sort of cut out, you know. I guess thinking y'all should already know some of these. All right, going the other way, we're going to express as a single logarithm. So you're going to go the other way. You're going to take stuff that's being added, write them as products. Things that are being subtracted, write them as quotients. Okay? And if exponents are in the front, we're going to move it back to the. So we're going to do counter moves to everything we did. So this is number 12. Log C of 67 plus log C of 59. So they're being added, so I'm going to write them as a product, which will be 67 times 59. And then they actually simplify it to the part where you multiply them together. So my final answer will be a log C of whatever that equals. So let's see what you got. 67 times 59.
3,953.
3953.
Yes.
And be done. So if you find these being added, you're going to write them as multiplication. So this one has a log of 100 minus a log of 10. Subtraction, so you're going to write it as division. Distribute the log out, so you get a log of the 100 divided by the 10. Hey, we can simplify that down. That'll give me the log of 100 divided by 10 is a 10. So y'all, technically that'd be the answer, but then they ask you, this simplifies further. Because remember, there's not a base here, so it's automatically a 10. So what does it equal when the base matches that result? Well, put it on front of that calculator.
What's that?
Punch that log. You got a log button right on the front of that thing, right by the 7 over there. So punch in log of 10 and see what I get.
1.
1. So the final answer would be a 1. So on number 13, it has you break it down to get the log 10, and then it'll say, well, this simplifies further, and you get to the 1. Okay? All right, 1/3 log C of x plus 5 log C of y minus 4 log C of x. I don't think my screen's frozen. All right, so we're back on there. All right, so first thing I'm gonna do, put all the exponents back up on top. So I'm gonna move this 3rd up, the 5 up, and the 4 up. So I'm gonna get log C of x to the 1/3 plus 5 log C, log C of y to the 5th minus log C of x to the 4th. So now remember, if they're positive, they're going to stay on top of it. If they're negative, they're going to the bottom, okay? So then I'm going to bring out that log base C. On top, I got x to the 1/3, y to the 5th, all over x to the 4th. Okay, so remember, if it's positive, they had to come from the top, and if it's negative, they had to come from the bottom. So we're technically done, except you cannot have x's on top and x's on the bottom. So what we're going to do, since those x's are bigger in the bottom, we're going to subtract 1/3 from the 4. So the top is going to stay y to the 5th. So as that calculator, what is 4 minus 1/3 going to give me? And then keep it as a improper fraction. We don't care about definition of our stuff. So I'm hoping y'all get something like this. So I need to do 4 minus the 1/3. Let me see where y'all are at. That's it, perfect. And then, since I got y's on top, x's on bottom now, I'm done. So y'all just remember, you cannot have single variables over the matching variable. You gotta subtract the exponents, okay? And the trick is to subtract the smaller exponent from the larger exponent. Well, hell, I might even get finished with y'all. I don't even have to worry about writing, right?
Hell yeah.
Oh, I want to skip that when you go to 16. Ln x squared plus 10x plus 24 minus ln x plus 6.
Is that 24 or 2y?
24.
Okay.
Mhm. So it's being subtracted, so the positive is going to the top. What's being subtracted is going to the bottom. So this will be an ln. The top will be x squared plus 10x plus 24. The bottom will just be the x plus 6. So technically, we're at the right answer, but this is not simplified all the way. So when you got polynomials over each other, you got to see if there's any common factors that we can cancel out of that. So I'm going to say this. The bottom does not factor, but the top definitely will factor. So let's bring the top. We're going to put the top into 2 sets of parentheses. Now I know the bottom's not going to factor. In some of these questions is why I did a lot of factoring with y'all. X squared means that's going to be an x and an x in the front. The last sign's positive, so both of these will be positive like the 10 in the middle.
6 and 4.
And all you got to do is find the factors of 24 that equal 10, and that was
6 and 4.
6 and 4. So now what can you do to that?
X plus 6 and x plus 6 have to cancel out.
So my final answer. Now watch this. In this final answer, you have to keep the x plus 4 in parentheses because it all applies to that single ln, okay? And that makes have 4 answers for you, so you gotta get one of the 4 answers, right? Now, we'll say if you use the quad formula to factor something, the quad would give you -6 and a -4 for the answers. Just remember, those answers, when you put them in parentheses, always got opposite signs. So you could have did the 1, 10, 24 on quad and got 2 negatives. Just remember, make them exact. Remember when we was doing we had all the zeros and we had to set them equal to 0, and then we put all the parentheses together, and then you started pulling and everything. Okay. Just remember, anytime you put them in parentheses, it's always opposite signs than what quad's giving us. Okay. Actually, one more of these. But I will say the factoring in this section is not going to be too bad. They keep them sort of light. Oh, this one's a log. A log x squared minus 5x minus 14 minus a log x squared minus 4. And really, anytime you see an x squared, that ought to be making that factor button go off in your head, you know. All right, so this will be on top, that'll be on the bottom when I rewrite this. So I get log x squared minus 5x minus 14 all over x squared minus 4. So y'all, I'm going to tell you this. Both of these are going to factor. So the top, x squared is going to put an x and an x. Last sign's negative, so you got one positive and one negative factor. So since the last sign's negative, can I find factors of 14? That'll subtract and give me a 5.
2 and 7.
2 and 7. So the 7 larger number has the same sign as the middle. So if you add a -7 and +2, you get that -5 in the middle. X squared on the bottom is an x and an x.
Plus and minus 2.
Plus or minus 2. There you go. So that's the difference of perfect squares. But guess what?
They cancel out. X
They
plus
cancel
2.
out.
X plus 2.
Now I'll tell you this one, you can do like this. Since you got the fraction here, you don't have to put these ones in parentheses. Because remember, on fractions, MathLab automatically thinks there's fractions, there's parentheses around your top and bottom. Okay? But the reason this one had to have the parentheses because it didn't have the fraction letting me know that the whole thing was in the parentheses. Okay. All right, so hell, I'll do the one I missed. I'll do 15. ln of x to the 6th minus 3 ln cube root x to the 5th. So the first thing I'm going to do, I'm getting rid of that radical. So I'm going to have an ln of x to the 6th minus 3 ln x to the 5th raised to the 1/3. All right, so watch this. This ln x6 is coming down. I'm going to multiply this real quick. So I got a 3 ln x. 5 times 1/3 will be 5/3. So all I did was multiply them exponents real quick. So the next move, that 3 in front of that second ln, guess what? It's got to go back up. So this needs to come up, and it's going to multiply by that 5/3. So what I need to know, what does 3 times 5/3 give me? 5, because I'm 3 is going to cancel, right? So that'll be an ln of x to the 5th. So now we're finally to the point where they're being subtracted. I'm going to write them as division. So this ln's coming over. X to the 6 is on top over x to the 5th. So what's happening to that x to the 6 divided by x to the 5th? X to the 1. So here all I'm doing is subtracting exponents. And then get my final x to the 1st, okay? So y'all watch out, the trick on these is being able to, about a third of these or a fourth of these, you gotta convert out of them radicals, okay?
I have a question on 17.
Mm-hmm.
So after we did x squared minus 5x minus 14, and all that, okay, so where you did, yeah, so the next step, how did you get there? How did you get all that?
Okay, so I had factor this and factor this. So when I factor these, x squared, I put x's in front of both parentheses. Anytime this last number is negative, you're going to have unlike signs. And then I found factors of 14 that would subtract and give me the 5, which would be the 7 and 2. I'm going to tell you all the trick to do on that. If you don't like factors, what you do is quad this. On the top one, you would have quadded a 1, -5, and what, a -14. That would have gave you a 7 and a -2 if you did it on quad. But remember, quad's giving you answers if you got them set equal to 0. So anytime you want to factor this, and it gives you these signs, change the signs of what quad's giving you to actually factor it. Okay. Now this one, 1, 0, -4 would have been what you put in. It would have gave you a 2 and a -2. Just change them signs and put them in those parentheses. Okay. So here I found factors of 4. That was subtracted to give me a 0, and that was a 2 and a 2. Here I found factors of 14 that subtracted to give me the 5, which were 7 and 2. Over here, this was positive, so I found factors of 24 that added to get 10, which were 6 and 4. Okay. That's the only thing about when y'all come straight into college algebra like this, or transitional algebra and some of them, they do more factoring than we do. That's why I show y'all so much on the quad. So I'm gonna see if you got that quad idea down that I just gave you, okay? You got quad program on that calculator, right? So back to this one. X squared plus 11x plus 24. So see what you would actually factor that into.
1, 6. 4 and 6.
Oh, I got it in there. He said 4 and 6.
Yeah, that's wrong.
So let me see what you mean over here.
Oh, I haven't gotten anything yet.
Okay, so program. Oh, you need the program. No.
I thought I had it.
You must have switched batteries or something. Okay, so
7 and 3.
Like the beginning of the semester.
yeah, so what happens is if y'all switch batteries or there's a never hit the green button, the blue button and the plus button, because that does the memory, and sometimes you clear the memory. So you gotta watch them. What was your number?
83.
There you go. All right, now you should have a program sitting right on that bad boy. So now hit programs or your phone. Actually, I gave you my factory program too. Oh hell, what's screw quad? That's his factory. Put in a 1, 11, and 24 on there. So I think, let me see if I can get that factory
Yeah,
program.
I believe it. I don't know if I've ever used it, but programs,
Yeah, number 7.
number 7.
It'll actually factor it in the frequencies if you do it, and you don't have to do all that quad stuff.
So when you
Same thing as
write down,
quad.
like I had quad like 1, -5, -14, so it'd be like 1, 11, 24.
Yeah, try that real quick. That get you back there? Did you get that?
Would you look at that? It was about 4 weeks ago.
Yeah. That's it. And then factors it into X. And then on the other one, you can put in, so if you're doing something like this one, x squared minus 4, you have to use a 1, 0, -4. Whatever's missing, there's got to be a 0 on those, okay? All righty, so we're done with that section. So I will see y'all Monday to solve equations.
No class on Friday?
No, we got everything done we got for the week.
Okay then.
So that'll get y'all through, what was this, 9,
9-5.
5. So next week we got 9, 6, 9, 7, and that's it for my year for y'all. And then everything else we studying for finals, I guess, right? All right, y'all, so I'll send y'all out this video as soon as I get it loaded. And y'all have a good one.